Yeah.
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 I watched a TED Talk on
Yeah,
that
it
one
is.
time,
I feel like
are
everyone-
people
There's my
actually
backpack,
getting
okay.
faster as technology
I don't know.
getting better?
See if it focuses
And
eventually.
They compared Jesse Owens' time to
I don't like just any
Usain
any
Bolt's
kind of
time.
word
At
problems. I
first,
just don't like.
They were talking about
If I have to
Jesse
read more
Owens
than a
being
sentence,
qualified
then
for the
Chemistry
Olympic.
is all word problems.
No, but that's different. I'm
Well,
talking about math.
if-
Like
but
it's
if you accounted for everything that
because then I have to
Usain
start
Bolt
like
has,
collecting
Jesse
like
Owens didn't.
what I'm using to
He was
calculate whatever I'm
losing like 3 or 4
calculating, and I have to
places.
organize it in my brain, and my brain's
And the
just not like
difference
that.
in the
It's
timing is
It's
like
not. It's not built
like
different. It's,
three-
All right, guys.
300ths of a second.
Any more questions from homework stuff?
maybe like I mean, what are we willing to go over right now?
Try me.
I mean, I've
Hold on. Let's.
This is 11-1, number 15.
Oh yeah. I mean, right.
Two.
That's how I know it's a bad one.
Negative 4/3. Good lord, 8 nice. So on the later ones, you can tell what's happening,
Yeah.
right?
You're multiplying each term, I think, by negative 2/3, yeah.
Negative 2/3, good. So what is negative 2/3? What symbol do we use for that?
That'd be
What kind of sequence is it if you keep multiplying by something?
Geometric.
Geometric. And what letter do we use for the number that we keep multiplying by? N is the sequence element I'm at. Like my first element, that's n equals 1. R. R. Okay. And then it asks, find a formula for the general term a of the sequence. Yeah, okay. So can you put that together? I mean, is that enough to keep going? Because you caught the idea of the sequence. So A1 is negative 3. A2 is negative 3 times negative 2/3, right?
Mm-hmm.
So this is there. So A3 would be negative 3 times 2 of these, right?
So it's
So what, this is times how many of these? None. So that's a neat trick to remember, right? Later you see one of these, 2 of these will go backwards. That must have been there was none of them here. And why is that important? Because that tells you where n, so what's the power going to be? N minus 1. Okay, that's enough. I think I've done it twice. Maybe? So if I ask you what does this series add up to, would the series be convergent? This is a sequence, everybody, right?
Yeah.
So today we're going to talk a little bit about sequences versus series. If you get them confused, you're going to get everything wrong. That's a bad place to be.
it converges because R is less than the
That's
absolute
your value.
value of R is less than
Yeah.
1.
Oh,
So the absolute value of R is less than 1, which means if I put this
I was looking at this.
into a summation, it would converge.
Mm-hmm.
In fact, what would it converge to? What would this sum equal?
-3/1 minus 2/3. Or 1 plus 2/3.
A over 1 minus R,
Yeah.
right? So then negative 3, good.
5/3.
Over 1 minus negative 2/3, yeah?
So 1 plus.
So 9/5.
Yeah.
Blah, 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 blah. Okay, so the point is, if it's geometric, right, then I can write the sequence very easily, right? The geometric is awesome because then I can write the sequence elements as just AN. I can put that together. You guys can put AN together. That's all it's asked for, correct? And then I added onto this, what if I put the sequence into a summation, so then I make a series out of it? Would it converge? Yes, and then we can see what it converges to, right? Because R is less than 1. Absolutely.
78.
Real, sorry, anything else on that?
Oh, it's fine.
Is it good? Okay, yes.
78 on 11.2.
11.2. So graph the curves. Oh yeah, is this x to the x?
X to the n.
X to the n?
Says graph the curves y equals x to the n
Okay.
for x is
Yeah.
less than.
And they give you, I guess we could, assign that one. I really don't like graph and this sequences.
You gave us a lot of graph problems on this one.
But not like graphing sequences, I don't think. Did I?
Kinda.
Kind of? Okay.
I think I got like 2.
But this is one they have to do on the graphing calculator. So at some point, x to the, oh, this is just x to the n, okay.
So what you're saying is just don't do this problem?
When it comes, no, this is better than I thought. I thought this was a sequence. Don't get too excited. I mean, anytime. You can not do a problem. That's fine. If you want to not get full credit. Oh, okay. I like it. Oh, that kicked so much ass. Okay, so for example, they want you to graph this, where x is between 0 and, is it equal to 1?
Yes.
Where'd it go? There it is. Yeah, x is between 0 and 1, and n is 0, 1, 2, 3, blah, blah, blah. So, for example, what would, if I let n be 0? What is that?
It's a 1.
1! Okay, so that's y equals 1. What's this? What if I make n 1? So then I get x to the first. And that would be this line, right? So this would be, so this would be 1, 1, there. They want you to find this area between those two curves.
And that's just a triangle.
Now do y equals x squared, right? Let n be 2. That would be this. Now find that area. You understand it's asking for areas between successive curves. So the area between x to the 0 and x to the first. The area between x to the first and x to the second. First, x to the first, x to the second. This sounds like a calculus 1 problem. Sounds like many calculus 1 problems. No? How do you find the area between 1 and x? Y equals 1 and then y equals x.
Just the integral.
What's
Yeah.
the top function?
1.
1. What's the bottom function? X. From 0 to 1. And actually this told me 0 to 1, so I shouldn't even be going out there. We are. That's a neat picture. Sorry. Alright, is that hard? Nope. What would the next area be? The red area.
X2
0 to 1.
or x squared minus.
Yeah, x squared. No, what's on top though? Here.
X.
What's on
X.
top?
The X.
X. Because when you square it, goes down for numbers between 0 and 1, it gets smaller. So it'll be x minus x squared. Do that integral. You're trying to find, let me make sure I remember what the question said. Find the areas between, so give a geometric demonstration of the fact that this sum is, oh yeah. So keep going.
Wait, so what's the question? What's our, what are we answering though?
So I don't know how you could even get to what they're asking until you do the first part. Have you done the first part? Have you done this?
Yes,
Have you done this?
yes, but
Have you
it's,
done the next one?
no.
Okay,
But it's like,
keep going.
I just keep going?
Yeah, until you can see the connection between what they ask you to look at and what they try to show you to compare it to. Right, that's summation.
Oh, so am I proving that that's the answer? Like that's the
All right,
equation for the series?
What do you get here?
Graph y equals x to the n for all values of x.
What's that?
between
Somebody
0
asked
and
what the
1.
question was?
Yeah, what was your
Oh, this is
finding
number
area between
70
successive curves.
8.
And then you have to, I don't know.
This is 11.2.
Yeah.
11. This said graph y equals x to the n from 0 to 1 for these n values, right? So when n is 1, when n is 0, we get y equals 1. Shipping! From 0 to 1. And I just want to get y equals x. So this purple area is the area between successive curves. The first curve and the second curve. So what is this integral? Is this cool? 1 minus x. That would give me the area between those. Right? Good old calc 1. Integral of 1 is?
X,
Integral of x is?
x squared, or 1
1/2
over,
x squared.
1 over,
When I plug a 1, I get 1 minus a half. It's a half. When I plug 0, I get 0. Right? So I get 1/2. I'm gonna guess you're gonna get 1/6 here. Let's see. What's the integral of x?
1/2
1/2
x
x.
1/2 x squared. That's crazy. What's integral x squared?
1/3 x cubed.
From 0 to 1. 0 is going to give you nothing, so when I plug a 1, I get 1/2 minus 1/3 is 3/6 minus 2/6 is 1/6. How did I know that? I don't know.
And then when you do it for,
I bet you the next one's 1/12.
and it's just gonna, the area of that's just gonna be 1, right? Like as you keep doing curves, it's gonna come.
Well,
to
because
a
this is neat.
Yeah,
You
it just
see,
turns into a.
I don't want to
a
necessarily do
square.
that, but yeah, as you do it, where's cubed going to be? Cube's going to be even a little bit further down than squared.
X to the million.
X to the millionth will be.
Really like close to the x-axis, and then it's gonna basically, yeah, it's just a
So
square.
as you do areas between curves, what would all the areas add up to be? The area of this box. What's the area of this box?
1.
Frickin' 1.
Mhm.
That's all I'm gonna say. Shit. Okay. That's all I'm gonna say. Anything else? So I'm gonna say about that problem, by the way. Not say stuff about other problems.
For 11.1, number 30, to find out if it diverges or converges.
Oh, somebody got what they want from this.
Wait, just one more time.
Can they take this one away? This is old, I think.
Yeah.
I still don't understand what the question is. We're just graphing it then?
Yeah.
Okay.
And then take a couple of the intervals until you see
Yeah,
the
you have to
pattern.
like actually recognize the pattern. Like you did kind of like telescope it a little bit.
Okay, that makes sense. It's just like it's like there's
What
like
was it? 4?
there's just no question.
4 to the n over 1 plus 9 to the n. So this is the book way.
Guys, so today we're going to talk about a few different ways to look at series that involves stuff like this. When n gets really big, what piece of this doesn't mean anything relative to the other pieces? When n gets really big,
1.
the 1 doesn't mean shit, right? I like to say, if Bill Gates walks out somewhere and drops a dollar bill, is he going to be desperately, is he going to love you if you pick up his dollar bill and give it to him? Oh man, what would I have done without this dollar? So if you have a lot of money, $1 bill is not that big. If you're a Jeff in college, a dollar bill is huge, right? So,
A wild Jeff.
remember what we did with stuff like, n squared plus 3n over n squared, 3n squared, sure, Jeff, minus 2n plus 1. Remember dividing by n squared? Divide by the highest degree term, right? We can actually apply, I think I showed you, you can extend this idea. What's the most quickest growing piece of this whole thing?
9n.
9 to the n. So if you divide by 9 to the n, on the top you get this, right? And on the bottom you'll get this. As n gets really big, what do both of these do? So then you just get 0 over 1, right? So of course this is a limit that I'm doing.
What question is that?
It was number 30 on 11.1.
So that it's really a nice idea. The whole thing you did for horizontal asymptotes back in pre-calc, we can extend that to things that aren't polynomial in nature. Nifty. But also at the same time, eventually we're going to get to the point after we do some stuff, and we're going to say exactly what I just said. When n gets big, that's shit. What does 4 over 9 to the nth do when an n gets big? It goes to 0. Done. I don't need all that crap, right? But we're not there yet. We got to go through some stuff. Okay.
Wait, so for that question, I'm not allowed to just know that 9n increases faster than 4n, so it would go to 0?
Well, technically, it's that simple, yeah. But I do want to see a little something. Yeah. For now, I want to see a little something.
Okay.
Right. Eventually, we're just going to say it's obviously going to 0. Okay. Anything else? Yes.
79 and 11.2. I'm not sure if you assigned it, but it's in the online number.
Yeah, it's in there. It's on. It's everybody.
Okay.
Okay.
Yeah, 79's horrible too.
I've done this so many times. I'm not gonna, alright, in the grand scheme of things, this problem, the reason this problem exists, the reason I gave it to you, is just to start thinking about, giving a picture of what can I get out of it, right? I mean, you have, so I've already done too much, to be honest, but I'll at least go over what I already did. This is a big parent circle, is a little baby circle, right? And it says these circles have a radius of one. Not just a straight line. And they want to know the diameter of the ever smaller circles, right? The little snowman that's in there. The infinite bodied snowman. Okay. Sorry. This looks like he's happy. So this is 1. What's the radius of the little circle? What do you want to call it?
R1.
Yeah, we'll call it R1.
I can't see it.
I know. He's just like a pirate or something. These are very proud parents of this little baby. Can anybody tell me what this would be? 2. So what's this here? 1. Okay, this is the right now look now. Okay. So what is this?
That's the hypotenuse of that triangle.
Yes. And what is it? It's 1
Plus R1.
plus R1. And that's 1. And this is good to know. Right? In fact, I can see what that is directly right now. What's this? 1. So what's this? What's this right here? What's this? R1. So what is this? 1 minus R1. So this this triangle here, that's 1 minus R1, that's 1 plus R1. That's 1. So one way to look at this side is it's 1 minus R1. What's another way to look at that side? Pythagorean theorem. So you'll have 1 minus R1 equals Pythagorean theorem shit. Solve for R1. Okay. I think I'm just kind of done with the problem. I mean, yeah, I can't remember, was it asked during class or right after class? Like yesterday or Monday?
Before class.
Before class ended, or before class started?
Yeah.
Okay. So not everybody saw that, but, because when I first was presented the problem, I completely forgot how to do the problem. So it was kind of neat to stand there and just, I have no problem with that. I mean, you guys need to understand, I don't care how good you get at math, you get a problem that you haven't seen maybe ever, you're not gonna know the answer immediately, you're not gonna know what to do with it immediately, right? So I think it's good. I don't want to get to a point where I'm sitting there in class and I'm just like, for 15 minutes, right? That would suck. But I don't want to, every problem I do be like, well, then you do this, and then obviously you multiply with it. It's going to make it look like, well, I can't do that shit. Well, I can't do that shit either, to be honest. Okay, enough of these happy circle family. Yeah. Yes.
I have a question. So 35 on 11.1, it says find if it diverges or converges.
35?
Yeah.
Okay.
It's the -1 to the n over 2 root n.
Okay. This alternating part doesn't matter. I really want this to make sense. As n gets big, what's the most the top can do?
Negative
Change
1.
signs.
If we go
1 to negative 1, 1 to negative. What's the bottom doing?
Infinity.
Growing. So the alternating part, the oscillating part of this doesn't really matter if the bottom, so like if you look at this sequence here, yeah, my negative. Right? What's that obviously going towards? 0. Now I'm not saying that's this, don't get over some, but I mean that's obviously going to 0, but is it going to 0 from one side? No, it's attacking you from both sides, right? Oh, it's like Nightcrawler, right? Oh shit, major geek. So he's over here and then he teleports over there and then he teleports over there, and he's coming at you, like, oh shit. Okay, so he's on one side, the other side, one side, the other, but it's still coming. So that's what's happening here. All that matters is if you take the limit, but you ignore the -1 piece because this is finite. right? So it almost, in general, it sucks if the limit you're trying to do and it's going negative positive, but what matters here is the bottom is definitely a bigger degree than the top, because the top's basically a constant. So the bottom's gonna overwhelm it no matter what it's doing, right? Yes?
If you use the theorem in the textbook that
Yes.
says, if the
Absolute
limit of-
value.
If the limit of an absolute value of a sequence is zero, then the limit of the sequence is zero?
Exactly.
Or is that basically restating what you just said?
No, it's even more direct. So theorem 6 in the book says if the limit of the absolute value is zero, then the limit of the sequence is given is zero. But the funny thing about that theorem is that's the end result of the thought that we just put into the problem, right? Does that make sense? So the thought we just put in is why this theorem exists. We just came up with the theorem ourselves. It doesn't matter if the top's hopping between -1 and 1, the bottom's just growing. It doesn't matter the top is going between two finite numbers, the bottom's going to infinity. So it's going to 0. So that's why you can ignore the alternating piece. What's the absolute value of this? 1 over 2 square root of it. And that limit is obviously 0, right? Because the bottom's just gonna go to infinity. Maybe?
So it
Okay.
diverges to 0? Or converges?
What's divergent mean?
It doesn't approach a value.
I love it. It doesn't approach a value. This does approach a value. It approaches 0. So it's converging to 0. Does it have to be 0 to say it's convergent? No. So, anything else from homework? I want to do a couple things. Okay, first thing I want to do is show you this. This is the blue measles I was talking about. It's not a name I came up with. One of my students a few semesters ago called it blue measles. Everybody in here is one of these blue dots, right? Okay, but I want to preface what I'm about to say with this. I think you all know where I stand on online homework. Some people use it correctly. More people don't. It's just my observation over many years of teaching. So if you're using a website and you're using it correctly, I love you. You're doing great. Keep going. You're fantastic. Nothing wrong with you, right? It's these people that give me work. What's true about these people here?
They're doing the homework, but they're not.
They're
performing.
doing the homework, right? And I'm sorry if I'm being too blunt, but they're doing the homework, but they have like 40s and 30s overall average. Yes? You with me? Now, it's not impossible that they're actually doing the homework but getting that low. It's really damn unlikely, right? Okay. And if I take those two out, the line gets a little better. Real quick, anybody ever did any statistics? I don't know if you guys know what R is. R is about 0.5 something for this. Let me see if I can do this real quick. If I take, let me see, who was it? It was 8.3 and
R squared.
4.4. Here's everybody. 3. Yeah, this is 46 plus 8 and 3. If I take this out, and I take 4.4, 38.1, this out, my R value has gone way up, which means that the points line up better.
More direct correlation.
Look at these two. Something interesting about these two is they're also WebAssign people. If I take them out, this becomes almost linear. Okay. Again, what did I say at first? Is everybody using WebAssign cheating? No, definitely not. There's some people doing it great, doing a good job. Keep going. But there are people definitely not doing well, not doing the right thing. Overall, the trend is if you do more homework, your grade seems to increase, right? I like it. So that's the overall message to get from here. So each of you is one of these blue dots. There's way too many here. I am very concerned. Right, and again, this doesn't mean that they haven't done homework. Do you see how this person's done somehow 0.75 homework? Because I take off half credit for if just say correct mistakes, and I don't give any credit for, right? So if you kind of do that, plus I give 70% of credit for somebody who turns it in, but I haven't looked at it yet. I don't know, I do all this weird shit. So that's why this is a rough approximation of the number of homeworks actually done and understood. All right, that's enough with blue measles, I'm sorry, but kind of got lost in all the technical jargon. Do your homework, kids, is basically the tagline with this. Emphasis on the word do. Okay. Anything else before we get into new stuff? Okay.
I think I see Carmen. For the very top right. Are you the only one who did all their homework?
There are certain people you certainly can be able to pick out. Everybody's got the integral test handout. Let me know if you need one. Section 11.3 integral test. Oh yeah, before we do that, so go ahead and make sure you've got that. Let me do a few things real quick. Okay, so get that ready. We're gonna look at it here in a minute. Does this sequence converge?
No.
How do you tell? What do you do to see if it converges?
The horizontal asymptote is 2, right?
So
Or
you-
negative
sorry?
2. The horizontal asymptote is -2, which is, you take the limit to infinity, it'll be -2.
So does it converge?
Yeah. No.
Yes.
The
What's
two.
the limit, and then,
Negative two.
just like you just said, what's the limit as then goes to infinity of this?
-2.
I thought if it's not 0, it doesn't converge.
Hold on,
What?
hold on,
You're
hold on.
We're on a sequence, not a series.
Exactly. And that's my point. Okay. Everybody with this? For a sequence to converge, the numbers just have to eventually be approaching some value, and they all agree where they go, right? And they could do it either like this, or like that, or like this, right? As long as they're eventually getting arbitrarily close, epsilon delta, oh shit, getting arbitrarily close to some value. And of course, this is just the old thing about horizontal, so that limit is -2, so the sequence converges. Converges? Good job. What's it converge to? It's a -2. Now, what about this? Does that converge? No. Right? Why is this harder for these things to converge than it is for these things to converge?
Because they're adding an infinite number of numbers.
Yes, because this carries with it everything that came before it, right? I'm adding, so here, the first element is whatever the hell it is, comma, and then I just go to the next element. I don't carry the first guy with me. This guy's got to carry everything. The 20th element, the 20th term of this sum would be 19 plus the 20th element. Like, oh shit, right? So it's just got to carry everything with it. In order for this, so this series, why does it not converge? How do I know without doing anything else that it doesn't converge?
Because the limit of this sequence is greater than 0.
And the limit of this is not 0. In fact, the limit we know is -2. So at some point, I really want this to make sense. At some point, the elements become so close to -2 that they're basically -2 for most humans. Do you guys understand what I'm saying? That's the idea of asymptotic, right? -2.187,001 is freaking -2 to most of us humans. Yes? Okay, we were kind of rounded after we got to maybe 6 zeros. We would go, okay. So, at some point, I'm just adding -2 forever. That's going to go to -infinity, right? That's got no chance to converge. I really want that to make sense. So the test for divergence, given a series, if the limit as n goes to infinity of an is not 0, the series diverges. So if I give you a series and I ask you, is this convergent? What does it converge to? What's the very first thing you do? Freaking look at the limit, right? Because if the limit's not 0, you're done. You're done. You got nothing else to do. Okay, maybe. Rule out divergence. Okay. But, let's see. Oh, shit. If the sum of an converges, what's true about the limit?
Does not equal 0?
If the series
Or it equals 0?
converges, then the limit of the sequence elements must go to 0. So this is where students, now again, we talked about logic. If then does not mean the other way works. It could, but it doesn't mean it does. If the limit, so did I say anything about if the limit is 0? Have I said anything about if the limit is 0 yet? Nope. So what's the right thing to say here? If the limit is 0, what does this do?
And it
Yeah,
Converges.
may,
May
May
converge.
converge.
Might
yeah,
or may. I like could.
may is a good one.
April showers bring May flowers.
The Mayflowers sing their pilgrims.
I'm sorry.
Mayflower is the ship.
Yeah, I got it.
It's a dad joke to finish that saying. You guys with me? I said this before. In order for a series to have a chance to converge, the limit of the sequence elements has to be 0. It's the only way it could. If the limit is 0, it doesn't mean it does, right? Can somebody give me an example of a very basic little series that we know does not converge?
Harmonic.
All right. What's the harmonic?
1 over n.
What's the limit as n goes to infinity and 1 over n?
0.
0. So it's 0. So it could converge, but we know it doesn't. Right? Okay. You guys with me so far? So it's really, really important that we keep track of what's true for sequences and then what's true for series. They are separate things, right? Sequences just talks about numbers with commas, just the numbers. Series talks about adding up all those damn numbers. So it's going to be much harder for a series to converge. Yes?
Why?
Say again?
Why? That does not convert.
Oh, okay. So let's do. I can't remember. Did we
We talked about it, yeah.
do the integral test on this yet?
Oh,
So let's get into the integral
The
test.
integral test is what proves my
Let's get into the integral test.
capacity.
So everybody's got this right? Anybody else need that? Anybody else? You guys all got all the integral test handed out?
yeah, we did do the integral test. I have it in my notes.
Good. We're going to do it again.
Okay.
On this sheet, at the top, I've got basically what I just went over, which is awesome because I forgot I put it there. That's awesome. Then we got the integral test. So the idea is pretty straightforward. If I have the sum of the series, we'll go ahead and look at 1 over n. And I look at the related integral. Right? And if I do, for example, let's do this crazy thing. It's roughly, okay. So if I do, how do I say this? Yeah. So if I do this, remember Riemann sums? Okay, actually, it might be, let me do this. So you got it. Is that what I just did? I think it's what I just did. No. So this is going to have a value of f of 1. The area of this rectangle is equal to the first element of this. Yes? Does that make sense? Because this is 1 over 1. the height here is 1 over 2, right? So the area of this rectangle is equal to the second sequence element of this. Are you guys with me? Now, of course, to do the integral, the reason that this does not equal the integral is because the integral doesn't just stop there, does it? It freaking lets there be infinite rectangles, right? That's bugging me. Hold on. Shut up. Okay, so if the integral of this converges, then this definitely converges. It doesn't tell you what it converges to. So normally, geometric series are a little weird because normally I can tell if a series converges, but I don't necessarily know what it converges to. In fact, most of the ones we're going to look at, we're not going to have any way to tell what they actually converge to. Are you guys with me? Geometric, we know what they converge to. They converge to a over 1 minus r, when r is less than 1. Absolutely. Okay. So, this is a test to see if it's convergent or not. That's all this is able to do. So if the associated integral converges, then so does the series. So what happens here? What is the integral of 1 over x?
ln x.
Holy shit. And why do I not have to put absolute value? Because all my inputs are positive, right? Yes, sorry.
If we are.
Yeah, I know.
No, if we
No?
are doing a problem like this on a test or something, and we do put absolute value x on the ln, will we get points marked off for that?
No, because you're not wrong.
Okay,
Just too
just too extra.
careful. Yeah.
Okay.
Minus natural log of 1, right? What's natural log of 1?
0.
0. Oh, I'm sorry. I'm doing too much here somewhere. There we go, Jeff. 1 to t. Limit as t goes to infinity. Natural log of t minus natural log of 1. And of course, this goes to infinity. So this integral does what? Diverges. So the sum diverges. So, an immediate, really good question is, what power could I put on the end, and then it would converge?
2.
Is that the smallest power?
Anything greater than 1.
How do you know?
Because if ln1 is 0.
Can you
then-
prove it?
No.
Yes.
Okay.
What would be a good way to prove this?
Okay, I'll let
Throw
you
a base
think.
case out.
Yeah, throw.
Why don't we, okay. Why don't we do this? You ready?
Nope.
Some of that.
What's a really good letter to use for the power of something?
P.
P, okay. So let's look at this series instead.
Oh, PCs.
Some unknown power, right? Okay. Okay. So let's do the associated integral test. Some of you guys might be like, how do I do an integral? Well, I don't even know what that is. I don't know. Let's find out. So let's do like this. Is that cool?
Sure.
Right?
Sounds
That's
awesome.
what 1 over n to b is, and then negative p. From 1 to t, limit as t goes to infinity. D, oh, let's make this an x, sorry. Gotta make it an x for this to work. And why, real quick, why is that? Why doesn't it work if I leave it as n?
It's just
Yeah, so, because what's the area under points? They have 0 width, so that would be 0 area, so technically, the interval's not defined for sequence of for points, yeah. Okay. What is the rule for this?
You do negative p minus, or negative p plus 1.
Yeah, it works for every power except if p is what? What's the one thing? So in general, oh shit, I need more. Oh shit, somebody, oh shit.
Sorry,
In general, this is the limit as t goes to infinity of
P is -1,
then you can't.
the derivative of the integral of this would be what happens? The power goes up by 1, then you divide by,
so that new.
The new
value.
power. right? So that would be from 1 to t. So we're gonna figure that out in a minute. What's the one power? We just did it. Where? Negative 1 power. So if p is 1. So this is if p does not equal 1. If p equals 1, this integral is natural log of x, right? And we just did this one. So it diverges for p equal to 1 for sure. Now let's think about this. Let's go a little further. All right. Where can I do this? All right. This case doesn't work. This case, no good, bad. Let's look at this case and let's break this down. What if p? So let's get the result. It'll be t. The limit is t goes to infinity. T to the negative p plus 1 over negative p plus 1. And then when I put a 1 in, I get 1 to something is 1 divided by negative p plus 1. So, let's see. Minus, let's see what is going on. 1 over negative p plus 1. There it is, Jeff. You did it. Good job. Okay. We stop for a minute. Everybody with me?
Almost.
So, x to the negative 1 is the integral that doesn't follow the general rule for, like the answer to power rule, right? So normally the n came down and then went down by 1. Now it's the power goes up by 1 and the divide instead of multiply by that, right? So that's the answer to it. That's the backwards way to do it. So that's what we're looking at here. This is the one case it doesn't, and that diverges so I can eliminate p equal to 1. I'm trying to figure out what p will make this converge. This power is negative, sometimes. What if p is greater than 1? This power will then be
Always negative.
negative, yes? Which would make this go down. So this, if p is greater than 1, this becomes 1 over negative p plus 1, t to the p minus 1, and this would go to 0, correct? And minus 1 over negative p plus 1. So the important thing, it doesn't matter what the answer is, because it can't tell you the answer anyway, correct? The integral, the answer to the integral just tells me if it converges or diverges. It has not much to do with what the actual answer is. There's a little bit to do with it. We'll talk about that. This goes to 0, so if p is greater than 1, it converges to this, which means this series would converge. So far, if p is greater than 1, this converges. Meaning if p was 1.00000000001, that would converge. Right? But if it was 0.9999999, it would diverge. It's crazy. You guys semi with me? Maybe? No? You guys hate this? What about if p is less than 1? I think this should be quick. If p is less than 1, if p is negative, what's this power?
It should go into infinity.
Positive. So when I go to infinity, that's going to diverge. So the only way a series in this form can converge is if p is greater than 1. Okay? So, believe it or not, I'm walking on air. Believe it or not, we call this the P series. So, you see the book talking about the P series, this is what it means. Erase all this, you ready?
Is P series in 11.4? What chapter is P series in?
Say again, P series will now be anywhere it wants to be.
Well,
Once but we learned about 11.3.
We do learn about it in 11.3. I didn't know that.
And it shows up where it wants to after that. Yeah.
11.4 is
Comparison test. That's
But not before exactly. Good catch. So what do we know so far? We know these kind of series, right? So what if I had this? Does this answer really? Well, let's see. Does this series converge?
No.
Yes.
Yeah.
It's less than 1.
It's less than 1.
It's greater than 1. And it's a P series.
Is it in the right form?
You just gotta put it.
Oh,
1 over n to the
1.2. This is
is greater than 1, converge. Alright, don't let me get you on that type of thing.
It'll be probably in the test.
Huh?
It'll be probably in the quiz.
Of course it will. Shit. What's one big thing about mathematics is put things in the correct form, right? If I put something in the right form, I can tell what the slope and y-intercept is. If I put the circle stuff in the right form, I can tell what the center is and the radius, all this kind of shit. So it's all about putting something in the right form. Is that cool?
That's
Same
very
thing with derivatives, right? Put it in the right form, I can use the right rule, right? Oh, what about, no, I won't do that yet. It's getting a little weird. I mean, anything I give you is gonna be pretty straightforward. All right. There's one little thing we'll do later. Okay. So that's one thing we know, is how to test to see if this converges. Do we have a way to know what it converges to? No. No. What other thing do I know how to tell if it converges? Let's kind of do a review. Geometric series. So geometric series, which can be put in this form, it doesn't have to be in this form. Right, we've seen it in multiple different forms. I can identify A no matter what form it's in. I can identify R if I kind of tease it out, right? To get R, it does have to be somewhat in a certain form. And so I know if R is less than 1, absolute value, then it converges. And why does that make sense? Because if R is less than 1, I'm multiplying by something less than 1, so I'm getting smaller and smaller and smaller. In fact, I'm getting smaller quick enough that it goes, not only does it go to 0, but it converges when I add them all up. Yes?
Can I jump back to the P-series for a second?
Yes?
Connecting this back to something you said before, would it be accurate to say that P must be greater than 1 in order for the sequence of that series to decrease fast enough to get out of its own way?
Yes. Yes. You can use my parlance. I love it. My less than technical, but still getting the idea across parlance. It gets out of its own way fast enough if P is greater than 1. I love it. Okay. There's at least one more kind of type.
Telescopic?
Yeah, telescoping, yeah. And we did an example like that. Now this one, you can actually tell what it converges to, because you can do what we did last time to figure out a form of Sn, and then you just do the limit on that. So we did an example like that last time. Okay. So that's another one. It takes a little bit of work to figure out what this is. Not a crazy amount. It's pretty straightforward. You just got to use to just writing enough out so you can see what's going on. So if you're not sure about it, we did it last time. Take a look at the video. I love having those videos. Okay. Anything else you think? Is there something I missed? Now we know P-series. We just added that today. We've known geometric series and how to tell when it converges. We even, real quick, this is the weird one. We know what it's going to converge to. It's going to converge to this. And of course, telescoping is another weird one that we actually know what it's going to converge to if I can get Sn written, which I normally can. Okay. So in general, most series, I can figure out if it converges or diverges. I have no idea what that is, right? Okay, maybe. So let's look at a few things on this handout. Can you guys go ahead and do, see in the middle, 1, 2, 3, 4, 5? First one's easy, we already did it. Right, number 1, we did that one together, so maybe skip it. How do you show, real quick, the big thing about the integral test that I said last time, what's got to be true about the sequence in order to apply the integral test?
has to go to 0, or the limit has to be.
Decreasing.
Yeah, so use the integral test.
And limit goes to
An must be decreasing after some, did I put that on here? Up. When n is specific, decreasing continuous. Okay, sure. must be decreasing 4 and greater equal to 1. So one part of the integral test is going to be showing that the thing they give me is actually doing that. Verify one thing real quick. Blah, 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 blah. Okay.
Wait, so if you wanted to use the integral test on something like 1 over 2 minus x, you couldn't do that? Because of it's not continuous after x or x greater than equal to 1.
So it would be really strange to have a series like this, because at 2 it's got an undefined element.
Yeah.
So normally you would have this defined so that doesn't happen, or else it doesn't really make sense.
Okay.
Yeah. It's kind of like writing a series for something that's automatically not going to be good, so why would we even write it? Okay. Blah, 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 blah. Oh, I do want to say this real quick too. So this converges. Okay, here we go. If and only if, and this is the only time I'm ever going to write this phrase. From now on, it's going to be this. This is proof speak. If. So if and only if the integral from 1 to infinity f of x converges, where f of x is related to a f, right? Okay. If and only if means the if then goes both ways. So if I have an integral that converges, then the associated series converges. If I have a series that converges, then the associated integral converges. So we've had that talk about logic, and I think that has to happen the further you get in math, because you start to get these theorems. It's very important to understand the if-then. Means it doesn't go both ways. This is how we determine that it goes both ways. It's if this, then this, and it's if this, then this. It goes both ways. If and only if means goes both ways. Okay, I'll stop. So go ahead and try number 2. Let's see if you remember how to show something is decreasing. While you guys are doing that, what's happening Monday?
Quiz.
1102. I'll go ahead and announce another quiz on Wednesday.
Okay.
You're welcome. Because what's happening, so that'll be the, I'm not even gonna pretend like I know. What day will that be?
Well, what's today?
Yeah, exactly.
It'll be the 12th.
It's the 12th.
Alright, today's the 5th?
Yeah.
Alright, it's October, right?
That Wednesday's the 12th.
This is the 12th. What's gonna happen on the 19th?
Exam on chapter 11.
Wow, that soon?
It's in about a month.
2 weeks from now.
That's like, that's 4 classes.
Time flies when you're having fun.
Very true.
How many quizzes we have?
The time you slow.
I try to give like 2 for every test. Oh, I don't know. 4? I think it is. It's on the homework sheet. Yeah.
When's the final?
Say again?
When's the final?
Does anyone know when the final is?
Oh, it's like the Monday of the last
No, no,
week.
no. Do I know when the final is? No, but did I write it down somewhere?
Yes.
I wrote it down on the homework
Syllabus.
sheet and on the syllabus.
I was gonna say, isn't it the 14th of December?
14th, yeah. Is it the 12th or the 14th?
12th.
12th, okay.
I mean, I was gonna say-
6:05 to 8:05
There you
p.m.
go. I knew it was the Monday of the
Basically,
first week.
My brain. So if you ask me a question about what did you assign or what does that do or what, I'm like,
You just have to memorize that, we know calc two.
say it.
You just have to memorize that, we know calc two.
No. You memorize that, then you know part of my brain.
Um,
Part of it. Oh. I thought you said like the entire.
what am I doing?
Derivative
N
test.
is less than. Oh,
Derivative test.
I'm gonna show you a couple ways. One thing is, it's kind of obvious that this is decreasing,
Mm-hmm.
right? Because the bottom's getting bigger, so the whole thing's getting smaller. But I just want to show you a couple ways, in case you start to get stuff that's not so easy. One way to show it's decreasing is to just show it directly. So I want to compare AN to AN plus 1. If it's decreasing, what must be true about this compared to this?
Gotta be greater.
That has to be smaller, right?
Mhm.
If the next one's smaller, then it's decreasing. So this will be 1 over n squared. It's bigger than 1 over
Oh, yeah.
N squared. N plus N squared.
n plus 1 squared, right? You replace n with n plus 1. Stay with me. This is the long way to do this, by the way. This is really the long way. I can cross
Wow.
multiply,
Dang, he really said.
reduce those. Is this true?
Yeah.
Yes. Because n is definitely greater than -1/2. So that's one way to do it. I don't recommend that, but there will be times when you have to do it that way.
Really?
Is that a
What's another way to do it?
In a derivative test.
Derivative. So here's one way to show decreasing. You have to show it's decreasing. You also have to show that it's positive terms, but that's pretty obvious. Here's one way to do it. The second way is derivative. So if I look at the associated f of x, what's its derivative?
Negative 2x to the -1.
negative,
three.
negative,
Or.
wait,
negative-
what? -3.
Negative 3, I'm sorry.
It's negative 2.
Yeah.
So you subtract 1.
I'm thinking of integrals.
And what's true about that? Is it always negative? Is it always positive? What's my x value
It's
starting
always
at?
negative.
Where do my x values starting at? 1. So what's the bottom always? Positive. What's the top always?
Negative.
So what's the whole thing?
Negative.
Less than 0. Since the slope is always less than 0, it's decreasing. That's a very direct way to do it, right?
Mm-hmm.
There will be functions that we can't take the derivative of. For example, x factorial. We can't take it at the moment. I'm not going to say we're going to learn this semester, but there is a form of a derivative for that.
Wait, this one again?
Huh?
Calc 3?
No. I don't know. I can't. It's one of the things I learned somewhere. All right. Is everybody cool with that? I mean, so to be able to use the integral test, the terms have to be positive and they have to be decreasing. Now, okay, I'm gonna leave it there. So what's the associated integral look like?
1 over x squared.
Okay, from what to what?
1 to t.
1 to the t. Now, this is always fun, man. I can smell that when you're shifting gears from derivative to integral. I can hear it, the gears grinding, see the smoke coming. So what's the integral of this?
Negative x to the negative 1.
Okay, I like it from 1 to t. Right, so this will be limit as t goes to infinity, -1 over t, minus negative, so plus 1 over 1, right? And of course, as t goes to infinity, this goes to 0. What does this number 1 mean? Does it mean anything?
It means that the series converges.
Since it's finite, it means the series converges. The actual number 1 itself doesn't mean much to us at the moment. Okay, but it just tells me that the series converges. How did we already knew this converged, yes? Because this is a p series where p is greater than 1. Okay.
I use the P thing for, just say like,
So
can I use just the P thing?
if I ask you, is this convergent and why? P series. If I ask you, use the integral test, which I will definitely do sometimes, right, then I want you to use the integral test. Yeah, do number 3. Ooh, yeah.
Number 3, what's number? Oh.
I'm excited. Number 3 is awesome.
That is a cute use of.
Well, let everybody know.
Do I even?
Sorry.
There's like a 1, like a crazy person. I did.
What?
Everybody change that to 2.
Oh.
Pass Jeff. one
Just
to
make it
0.
1 over 0.
Yeah. So that would be 1 like we talked about earlier.
So if you have a, I mean, I know we're never going to get one because you said we're never going to get one, but if you did have one that said n equals 1, would it just be undefined?
Oh yeah. Then it would be automatically divergent because one of its elements would be infinite.
Okay, yeah. Is that what 1 over 0 is? Infinity?
In the context of allowing the bottom to get closer and closer to 0, yes. Yes. But if I just say, what is 1 divided by 0?
It's undefined.
That actually isn't infinity, it's undefined. Yeah, there's no number defined to multiply by 0 to get 1. Yeah. What do you have to be careful about here? Now real quick, the very first thing you have to do is see if it's decreasing, right? It's very obviously positive, yes?
Right, so for the integral test, I'm still a little bit confused. So we do the integral and then, like, if it's 0, then.
No.
Okay.
If the integral converges, then so does the series. If the
Okay.
integral diverges, then so does the series. Yeah. So the series will do what the integral does. So the integral could come out to be 87.3.
Yeah, so it doesn't
I don't
mean anything
care.
about the actual value.
Just means it converges, yeah.
Jesus.
To do what? Sorry. Oh, no, this is not a quotient rule. It's not really quotient rule because it's, well, I mean, you could look at it as a quotient rule. I wouldn't. I mean, this is like x ln x to the negative 1. Right?
Oh, yeah.
It's a chain.
Alright, so you get negative x ln x over 2 times ln x plus 1. Is that cool? The root of x is 1 ln x. X times the root of ln x is 1 over x, so x times 1 over x is 1. So you get negative ln x plus 1 over x ln x squared. Well, this, for numbers 2 and above, is always positive, and this, so the whole thing is always negative. Check. Decreasing. And obviously these are positive terms, right? So I'm going to ask you to check both things. So you just got to, say really quickly, yes, Jeff.
Can't we say that?
Positive or n greater than 2. Equals. So what do you gotta be careful about with the integral, since I made my little change to make this work? It should be integral from,
2 to, well, okay.
right, yeah, let's go ahead and do this. So you don't have to do a whole other step for that.
Yeah.
You guys doing okay? So you have two alternatives for decreasing. You have compare this one to the next one. That's a little bit weird. Now, really, this is one that you could argue, well, it's obviously decreasing because the bottom is increasing, but then you have to show me that, right? So just go ahead and do this. Very often with these things, it's going to be negative, bunch of positive shit, so it's going to be really obvious it's less than 0. Okay? You guys all right? Yes?
If you wanted to, we could show you, we could just take the bottom, make it a Sagoni function, and then show you the rate of that.
Yeah, if you took this on its own and showed me that that's increasing, that would mean that this is decreasing, yeah. Totally. That's where you can do a little creativity. How do you do the integral of this?
You said,
U is ln, du is 1 over x, so you get 1 over u, so you get ln of x. I'm just going to cut to the chase. Is that all right? ln of x from 2 to t. Well, here's where things get interesting. What's ln of 2?
Root 2?
like 693.
And what's ln of that?
Doesn't it just undo the?
Negative
It's a
output.
negative number, right? Okay, but it's negative finite number, right? So it's minus number. And then when I put a t in,
Yeah, just gonna still be infinity.
yeah, when t goes to infinity, this goes to, when t goes to infinity, natural log of t goes to infinity, which means natural log of this goes to infinity. So what's true about this then?
Divergent.
It diverges. Now, I really want you to stop and think about this. This is so kick-ass. Do you guys, what does ln look like of a graphic? Can you do it in the air for me real quick? Like that, right? Does it ever flatten out? It's always going up, correct? But it's one of the slowest damn functions to get up there. You guys agree with me?
Yeah.
It just looks like it's flat to us. You got to give it a long time to get up somewhere. Like, okay. So what I'm trying to say is, this is really kind of cool. If I took this and I made the power 1.0, and I do this 18 billion to the billionth power zeros, you with me? Would that converge?
Yes.
You can do it. P is greater than 1. It would converge. Is natural log of n enough to multiply by this, which is right next to something that would actually converge? Everyone, I want you to see this is kind of cool. Natural log of n effectively doesn't do shit to help. It doesn't do shit. This still diverges. Natural log of n grows so slowly, it doesn't help push this over, even though I would just have to make the 1 power become this, right? Remember 18 billion to the billionth zeros, right? Okay, I'm sorry. You guys probably don't quite understand what I'm saying, but natural log of x is just such a weird function. It's just so slowly growing, it basically doesn't grow. It's effectively what it does. It's just so slowly growing. Okay, I'll stop. Okay. I'll do, yeah, go ahead.
So if there isn't like an immediate kind of like thing that we can see, like a horizontal asymptote or something, is there a reason why we don't like go directly to the integral test and start there before going as far as like just?
Oh, you could get, again, you can get something in there that's not integrable,
Okay.
right? The minute I got a factorial in there, it's not integrable. There are things I could put in there that are integrable, but that you don't want to, right? So you'd rather have something else. So, guys, integral test works really well for easy to integrate functions, obviously. The minute they start getting rougher, and I mean beyond, like If you have to do a U sub and then a trig sub and then a trig integral and then you have to go back. So we're gonna learn, and again, there are plenty of functions I can't integrate, period. I mean, not even me, just nobody can integrate them anywhere. And we have to use what's called numerical methods, where we approximate the answer, right? I think I talked last time about finding the integral subroutine, all that kind of crap, right? Okay. Just to cut to the chase on part D, if I ask you on part D, because I don't want to do the end, you guys know how to integrate. Part D, is that gonna, I'm sorry, number 4. That's good, Jeff, I'm really tired. Number 4, is that gonna converge?
Diverge.
Why will it diverge?
Because it's a
Series less than
1/3
one.
power, yeah.
Yeah, P is less than 1, right? It's got it for a P series to converge. Now this is gonna suck a little bit. For a P series to converge, P has to be greater than 1, yes? For a geometric series to converge,
R has to be less than.
R has to be less than 1, right? So, okay, you just gotta keep that straight. This makes sense because the bottom has to grow fast enough so that it gets out of its own way. So that's why it's gotta be greater than 1. So this grows faster than just N, or just N ln N. This one makes sense because to multiply something by itself and make it smaller, I need the multiplier to be between 0 and 1. Yes, maybe? Okay. Let's see. And then number 5, you actually have to develop your own. Let's do 5 real quick and then I'll let us out of here early. How's that sound?
Oh, that sounds
'Cause
awesome.
I'm
Really
about
tired.
to keel over. I'm tired. Number 5, you have to come up with your own sequence definition, right? Your own generator. Put that in series form, right?
I kind of really go 10 over E.
Oops. Give everybody a second.
Yeah, for real. Jesus. Haven't even written
Sorry,
it down
Robert.
yet.
Just give everybody a second. Not everybody can see it that quick.
I try to put everything in my notes too, so it takes me a little second.
You know what I put down there? Oh.
Yeah, that's because I thought we were just gonna do one. I'm like, oh, this one's already dead. I'm like, I'm not reading that right now.
All right. What's the top doing?
It's just going up with N.
N, right? Because when N's 1, the top's 1. N's 2, the top's 1. Okay, great. Because you can put it up here, N equals 1, equals 2. What is happening to the power? The E is always there.
It's going
Power
up.
is getting like.
It's going up by N squared, yeah.
Yeah. That is yummy.
It's a cool function. I like that.
That's
Did you come up with that?
Huh?
Did you come up with that?
Yeah, I do. I make all my own shit up. I don't do test generator generate.
That's pretty cool.
I was gonna ask something, but then I realized.
What's the first thing we gotta check? Is it decreasing? What's the second thing we gotta check? The positive, right? What's interesting about E? Can I raise E to a power and make it negative?
No.
Nope, asymptotic is 0, so that's always positive, and N is always positive because it starts at 1 and goes up. So it's obviously positive. Can you show me it's decreasing?
I mean, by looking at it.
Yeah,
goes
looking at it.
faster.
It's a
But technically, alright, this one is pretty obvious. The bottom is growing stupid fast, and this is just linear growth, right? This is exponential growth. In fact, this is exponential growth. This is exponential quadratic. I don't even know what to call this damn thing. And that's only linear. But if you had a teacher, that very evilly said, "Prove to me this is decreasing," what would you do?
I take the derivative.
Okay, take the derivative. Okay. So what is this guy's derivative?
I don't even
I would
know.
write it like this.
I was gonna say, I would not take the derivative.
So it's e to the negative n squared, right? Plus n times e to the negative n squared times chain rule? Yeah, so negative 2n e to the negative n squared. So I get e to the negative n squared times 1 minus 2n squared. Is that cool? for n equal to 1 and above, what's this? What did we just say about this? This guy's always positive. For n equal 1 and above, this is always negative. So this whole thing is negative, so it's decreasing, but decreasing. That's what that word is. Check. It is. Alright, and now, yes.
If we wanted to do just the derivative at the bottom, how would we represent that? Like, would we draw, would we say f of x is equal to e n squared?
Sorry, if you want to do what now?
If you want to do just the derivative of the bottom, like how would you do that?
No, I need to put your question in context. In this problem, you cannot do just the derivative of the bottom. But do you mean if it was, if I,
Oh, because it's not a constant on the top. Or,
I'm not sure what your question really is. You could do quotient rule on this
it
if you
shows
wanted to.
decreasing, I mean.
Huh?
Oh, never mind. That's-
Oh, I see, you can't do the same thing before, cause yeah,
Yeah.
it's not a run on top, oh, this is from before. So now what's the interval gonna look like?
The limit as t approaches infinity.
I like it. Said with the correct tone.
One to infinity, t.
X times.
That is not a.
And how do you do this interval?
That is-
U equals x squared.
Yeah, it's a U sub, right? There's a function in there, whose root is in there also.
That's weird.
What happened, what?
They were
Turned
like,
around, he was
that's
like,
it.
that's a U sub in front, I was like, that's not a U sub. Directly, like 1 second after, you're like, so this is a U sub?
Oh man, that's pretty good time. So please, dear God, rule out U sub. And actually rule out just, is it just a straight up integral? Okay, this is obviously not a straight up integral. Take a minute and make really sure that U sub won't work. U sub is so much better than by parts. Sometimes you won't be able to use U sub, too bad. You'll have to do by parts, right? So I want you to realize the interval test opens the door back up to anything from chapter 7 that we did could show up in here. Yes? Okay. So u equals x squared, du equals 2x dx, so I need a 2 in there, spam. So then I get du and I get e to the negative u, is that cool? And what's the integral of e to the negative u?
Negative e to the negative u.
I just put 1/2 out there because I want to. Yeah, negative e to the negative u, and u was x squared, and x goes from 1 to t. Technically, I should do this there, because that's not what u does. U doesn't do that. Okay, so when I put a t in, since this is a negative power, when I put a t in, let it go to infinity, go ahead and write it.
It like goes to.
This is actually negative 1 over e to the t squared. So this limit would make this go to 0. Minus and negative. Plug a 1 in and I get e to the negative 1. So it's 1 over e. And it doesn't matter that it's 1 over e, it just matters that it's finite. So what does this do?
Approaches 1 over 2.71.
So it's convergent.
I can't say shit about what this becomes. All I know is that this converges. The answer to the integral
okay.
doesn't directly mean anything. The fact that it converged means our series converges. Check, yay, that's it, everybody, that's it. Good job, okay. So, I did, yeah, okay. I'm gonna hold on to these till next time, I don't wanna give this to you yet. I got a handout for 11.4, that's crazy, so next time, we'll do the quiz. Wait, what is that, is today or Wednesday?
Yes.
Okay, well, shit, Jeff. No, I don't wanna do this right now. So then don't, yeah, we're not gonna do it. So we'll just have a quiz on 11.3. I don't know if you noticed, the quizzes, I try to make them on the same day that homework is due, right?
Mhm.
So since we didn't do 11.4 yet, 11.4 is not gonna be due next Wednesday yet.
Then that'll just be doing the exam.
Say again?
It will just be a different exam.
We
correct?
would do the following Monday, sort of, you know, the exam date is the hard date.
So should we plan to have a quiz the Monday after next Monday too?
No, because Monday's gonna be a review day.
Oh, because our
So I
test.
wouldn't give a quiz on the Monday because you wouldn't get it back before the test.
So no quiz for another.
No quiz on that Monday. The following Monday after. A week after the next one Monday.
Yeah, oh yeah, yesterday I said.
Just these two quizzes.
Okay.
What is it like on that?
Yeah.
There's only three. Compared to.
You did. I just haven't granted it yet. Yeah. Yeah, I got it right here.
Well, no, the nice part about this one is they're like, whoever was somewhat considerate and they really like jammed it there and then smeared this one all the way up.
Man.
Well, no, you should look at it, the one he was sitting in. It's got like 6 or 7, if not more. No, yeah, it's more than 7. It's like 5, 6, 8.